This is a superspace short where I will be addressing questions and um, enigmas of physics which superspace theory might have answers to. So, one of the questions in physics is about infinities within mathematics. So, for instance, when we try to combine relativity, general relativity, with quantum mechanics, we end up with solutions of infinity, which, according to physicists and mathematicians, does not make sense. However, the idea of infinity within our universe can be shifted when we realize that there's a fourth dimension leading in what we think of as the direction of small, and that when you look at our universe as a two-dimensional sheet, you can begin to see how this new perspective of the fourth dimension changes how we look at infinities. So first, if we draw a black hole here, that's curving space, or which rather is a hole in space, and the hole is the curvature. When we see that this is our linear space in a 2D analogy, and that alongside our linear field of space are deeper fields of space, and that this is the direction of what we think of as the very small. When we see this, that the very small is a fourth fundamental direction, revealing a fourth dimension, then when we have infinity as the answer to this unending curvature of space, we don't have to look at it as an infinite point. We can look at it as a direction. So it just leads into infinity in this fourth fundamental direction. So that's one way in which singularities are not problematic in the same way. And in fact, if you look at our space as a 2D sheet with deeper fields of space lying alongside it, leading in what we think of as the direction of the very small, then if we're going inward at any point in space, far enough, or what we think of as small enough, to where we get the solution of infinity to our equation, where an infinity pops up, we don't have to think of this as nonsense. We just have to think of it as that demonstrates that we're now going in this fourth spatial direction. So infinity can lie at every point in space without it destroying our ability to do math within this linear macro space, because we will understand that the infinities are speaking of a fundamentally different direction. So infinity could lie at every single point in space, and in fact does, in the sense that at any point we can go inward to the realms of the very small, which is moving in a fourth fundamental direction. And so, lastly, I just want to touch on something a little more light and fun, and that's the enigma that some physicists came up with, or mathematicians, saying that you can't, mathematically speaking, you can't take a step because in order to take a step from here to here, you have to cross half this distance, And in order to cross half this distance, you have to cross half that distance, and half that distance, and half that distance, and half that distance, and half that distance. And this halving of distance is infinite, which came to the funny conclusion that you cannot take a step according to mathematics. But in fact, when you see that we are moving through macro space, and that at a certain point as we go inward, we're moving this way. So what the math is saying is that there are infinite points along here, but those infinite points speak of this direction. And although I won't try to get into the complexities of this, I would say a macro object moving in macro space does not actually cross infinite points. And that, again, would take a little bit more exploration. But mathematically speaking, when we move into infinity, we're actually moving in a fourth spatial direction that is not what we are doing crossing this macro space. Again, that gets complicated because you could try to divide this up and say that it's not moving in that direction. But I believe mathematically that is what we're seeing. So when we, simply put, when we understand this fourth dimension, which is the direction of small, then many of the infinities that exist here are solved, or at least given solutions, potential solutions. And actually, I will do one more layer here. And we can go to white. And I just want to clarify again, real quick, what I'm saying here is that a macro object can be of different sizes, but when we reach the point of the very small, the subatomic, that is going in a fundamentally different direction. And one of the other enigmas of science that this can touch on, if we let it, is the fact that in this macro space, we've observed a cosmic microwave background that has a certain strength. But according to quantum physics, it predicts a vacuum energy, which is much, much stronger. And this has to do with the cosmological constant problem. But when you see the realms of the very small as lying in this fourth fundamental direction, you can see that this is exactly how it should be, because there are incalculable energies underneath, or lying under our field of space, but in a different spatial dimension. And so whatever is here as a microwave background can be much softer and could be a reflection of this, but what quantum physics is looking at lies in this direction, the realm of the very small, which is a fundamentally different fourth direction. So we're talking about two different things when we look at the cosmological constant problem. The vacuum energy is virtually infinite, but it lies in a fourth spatial direction of the fourth dimension, which is what we call the realms of the very small. So those are a few quick thoughts on the ways that superspace theory can address the infinities which pop up in physics and mathematics. And I appreciate your watching. Thank you.